Hello, today's video will be a review of a pocket-size multimeter, actually the cheapest you can probably get and the smallest, at least currently. It's a SAMWA YX-1000A. I should make a mention before that such models are still available on the market under different brand names. They are all built in China, so there is no surprise about that. And they feature almost the same specifications. An interesting note is that I started my activity as a hobbyist using a device that is vastly similar to this, and I can also relate to some of its shortcomings. But first of all, let me tell you what this meter can do. It can measure resistance in ohms. It can measure DC currents, of course, if they are not too large. They can measure AC voltages and DC voltages. Overall, you could think that, okay, it's quite a good multimeter to start your activity with. Unfortunately, it's not, and for a couple of reasons, which of course haven't changed in almost 2.5 decades since the product was first purchased or seen by me. The first obvious aspect is the probes. The probes are simply horrible, and the fact that they have a contact that cannot be best described as it just works, but of course not great. It has a lot of leeway when the probe's end is placed in the multimeter, and also they do not have great survivability. As far as I remember, I have attempted to repair the probes for a couple of times, so this is the first aspect that is going to get in the way. Possibly these ones might have a better survivability than the ones I had 20 or so years ago, 25 years ago, because I think you can take out the tips and then solder again the wires. I'm not entirely sure if this is possible, but the fact that I'm not seeing a single piece of plastic, probably you can see it slightly better here. The fact that I can see a slight ring inside, let's make an attempt at focusing, okay, means that there could be another plastic part that could be taken out together with the tip. The tip's quality is very poor, as you can see. There is some corrosion or indentation on the tip. They aren't well covered with chrome, so actually you cannot expect to have a good performance, and the tips are quite poor in the sense that they are not sharp enough. So anything you would like to start by using such a multimeter is going to be, let's say, with a lot of understanding. And moreover, I would say that it's not a good device for a beginner since it doesn't have any fuse. I have not been able to blow the meter when I first used it or later on. However, this is a concern that most users should have. Regarding the ranges, I think that they are quite poor in the sense of you can already guess at the meter's design age, meaning that it was probably somewhere in the early 70s or perhaps even earlier than that when such a multimeter was designed, because otherwise you would see no point in having a multimeter that is still being solved after 2000s or even after 2020 with a 1000 volt range. I mean, what can you check with a 1000 volt multimeter when you have such poor probes? It's almost pointless to think about that, and the cables are not any better. So in the end, I think that it's a poor choice to have such a range on a multimeter, and it would have been better to have a lower voltage range like 2.5 volts, 3 volts or something along the lines. And just as well on the AC or on the DC current range where I would have liked to have another lower range or lower scale, like, I don't know, 1 milliamp or 10 milliamps. In the case that probably 10 milliamps would have been better. But unfortunately, we don't have that. The scale is quite small. It means that it's highly portable. On the other side, the meter's accuracy is poor, as you will see, and it's one of the reasons why I will also feature another multimeter that you can find quite cheaply, the YX-360 series, and you will see just about why this multimeter is a very poor choice despite being slightly cheaper than the larger model. Alright, so let's start by making some measurements. The first choice would be, just to get out of the discussion, the resistance measuring capability. Alright, so let's make an attempt at having a good contact, which of course is not going to be that easy. And I'm expecting something along the lines of 0.4 kilo ohms. Let's see. Yes. As we can probably guess over here, it's closer to 80, if I say it correctly. Yes, closer to 80, which of course is very poor. Because we always need a reference, let me show you what value the other meter reads. Okay, so we are on the same scale. It's multiplied by 10. And let's see what value we find. Okay, 40 something. It's not bad because the same resistance, sorry for not making a good contact. Unfortunately, the probes are not that great, but I think this one, gives you some understanding on the current situation. Yes, I'm seeing something a bit higher than 40, because you have 30, 50, and this is 40. I was expecting something along the lines of 454 ohms, so the next division should have been presented. Fortunately, it's not going to be stable. And it's closer to 400 than it's to 450. Unfortunately, this is the accuracy of the meter, is not great, but you have noticed how far off the SAMWA YX-1000A is. So you cannot readily make a measurement with any reasonable accuracy. And this is a range where you can clearly see something. I can go on a lower range and have a measurement, but I'm doubting that the other multimeter will fare significantly better. Okay, so I on the 1K range, which would mean a lot of deflection, unfortunately too much in the case of such a low value resistor, so I cannot make an assessment. However, as you have seen on one of the ranges, I think the accuracy is very poor. And of course, in case you wondered, I have zeroed in the meter quite reasonably. Perhaps not the best. Okay, let's make another attempt to make the device shine. As you might have noticed, just by making a slight movement of the probes, the resistance goes all the way. So the contact is very poor, and this means that accuracy is largely doubtful. Okay, let's make an attempt at centering, at actually calibrating the zero on the device. And I think that that's just about as good as I can get it. Okay, let's make another attempt, because I may have been making a wrong measurement, and let's see how well. Now, as you can see, it's the same value. I wasn't expecting any change, but I wanted just to show to you that clearly this multimeter has very poor accuracy. Alright, let's move on to another measurement. Typically, almost 20 years ago, and even today, I was measuring 1.5 volt batteries, the AA, the AAA variety. Actually, there is no, this doesn't matter, it's the same type of battery. Let's see how accurate of a reading you can get with this meter. Remember, this battery should have 1.5 volts. Okay, as I'm reading on it, and I'm on a 10 volt scale, I can think about the values over here, however, note that those are for AC, so I cannot use the AC scale, I have to use the DC scale. So I'm going to imagine that each and every division, major division, is going to be a 1, and probably this one will suffice. So as you can see, 1 and 1 almost 1.2 volts. This is very far off the actual reading. Let's make the same measurement with another multimeter, and let's place it on the 2 volts range. Okay. As you can see right off the bat, it's a solid 1.5 volts. The other one measured only slightly less than 1.2 volts, which is very poor. And in case you wonder, yes, every division over here would translate to 0.2 volts. So the accuracy is abysmal in the case of this multimeter. All right, next test is the 9-volt battery, which should register around 8 volts. So it could give a good deflection on the 10-volt scale, which would mean that probably we will see the best accuracy this device is capable of, at least on the 10 volts range. Okay, and as I see it, it's less than 8 volts, probably something like 7.5, which is again a very, very poor accuracy. And if we're going on the same range, on the 10 volts range, let's see. And we have almost 8 volts. So between 7.8 and 8 volts, which means much closer to reality. So this device accuracy haunts it again, even when we are talking about the best it could probably show. I mean, we are talking about using the proper scale and having the right voltage to deflect the needle more than 50%. All right. What else can we measure? Unfortunately, I don't think that current measurement is going to be any serious. We can make an attempt. I don't know if we have something that delivers very little available, at least now. This one delivers 25 milliamps. Oh, 25 milliamps, great. This means I can use the milliamps range. Probably let's get to 500 just in case I make a wrong assessment of the current delivery, and make sure I make the correct connections. Okay, it deflected up to, let me think, 500. This means 100. Something along the lines of 50 milliamps, but I'm not entirely sure. Less than 50 milliamps. As I noticed, it was 20 something. It goes out of whack and centers at around 15 milliamps. Okay, 15 milliamps. Let's see what happens with the other multimeter. So we are going on the milliamps range. I don't have the 50 scale, so you have to take that into account as a small aspect that is in favor of this multimeter, and with this one is going to be slightly less favorable. So 25. 25. I had 27, so I actually have to go on the 250 milliamps range, which will probably result in less accuracy. And I can clearly see, okay, 250, 50, 25 is less than 25 milliamps, so probably around 20 or so. Let's see if I'm correct. It stabilizes at around, so it's 25 watts, something along the lines of a bit above 20 milliamps. a bit above 20 milliamps, and this one expected a value that was, let's see, so let's measure again 20 milliamps. Almost 20 milliamps. So I think that the DC milliamps range is actually the one that fares the best, at least in this particular scenario. Okay, not a great distinction, but one that we can probably live with. Let's make another attempt so that I have not made a mistake. Yeah, around 20 milliamps. So the small current range seems to be the most accurate in the case of this multimeter. Is not that far off from the other larger unit, and particularly in the case of this battery or other batteries, the multimeter current measurement capability is not going to be that important, because the battery will deliver a slightly different current depending on situation. The best scenario would be, and I can probably test that. Okay, let's make an attempt, though I'm not entirely sure it will make a meaningful difference. Let's see, 500 milliamps, and let's see if this is going to be enough in order to limit the current to a reasonable value. I have not made a definite contact. No, there was no current draw. Okay, let's make an attempt at reducing the range and seeing if we have something that can be measured in this circumstance. Okay, I think we have to go even lower than that. Let's see if we can. Okay, let's try and make a better contact. Yes, unfortunately, we can have too much accuracy when we are making this measurement. So on the 50 milliamps range, it deviates to around 1.5 to 2 milliamps, and let's see how much this deviates. Of course, in this case it's more advantageous because the range is smaller. So 1.5 to 2 milliamps, okay. Yes, 1 point something, 1.2, yes, 1.2. 1.2, 1.5 milliamps, and particularly when we're thinking about a scale that is double, I don't think the accuracy is that bad. So probably the only saving grace for this multimeter up until now is that it can measure low currents quite well. On the other side, the DC voltages are clearly not its strength, and it fares extremely poorly compared with other multimeters. We are not even talking about digital multimeters. All right, let's make an AC measurement, and let's see how well it shows. Okay, 250 volts. I'm not entirely sure if you will be able to see the multimeter because the test probes are quite short, and unfortunately there is a bit of a distance to bridge. Okay, let's see. So on the 250 volts range, as you can probably guess, it's 225, almost, I think 200, 225, 200, closer to 240, I would say. 240 225 plus 12, 227. Okay, it's quite accurate. 227, no, 237, sorry, so it's a bit off. 247, and if we are making the same measurement, and we will be on the 200 volts range with the the other multimeter. Okay, let's see. So 247 compared with, okay, I think I made the right connection. Sorry. And I don't know if you are able to see. Okay, it's 225, almost a bit leaning towards 227, I would say. It's not that clear, and of course when I'm placing the meter at slight angle, it's going to be better off. So yes, we are talking about a measurement accuracy that is very poor. So the SAMWA YX-1000A has very poor voltage and resistance measuring capability. The only saving grace is that it works decently enough as a multimeter, at least as far as I could test. Alright, just because I wanted to show to you again why this device is poor, I will also make a teardown of it. Sorry for the noise. Okay, and show you the insides. It's mostly barren, and the reason for that is that most components are actually placed on the front side of the board. They are SMDs, which of course is a difference compared with how the device was manufactured 20 years ago. Unfortunately, accuracy has not been improved, and I think that this is the most important concern I have. And also the fact that still you cannot see any sort of fuse on the inside, which means that the device fares very poorly in terms of safety. The contacts for the battery are also very poor, since I used a modern European battery, which of course has a slightly different size, different length than most Chinese one. You can see that the plastic is bent, so this fares very poorly in terms of long-term use. And the contacts themselves are flimsy, and they do not offer enough, they do not have enough elasticity. So I think that this is also another poor aspect, and the contacts, as mentioned, as poor as you can get. And more importantly, you cannot find, or at least I could not find 25 years ago or ever since, probes that could be used instead of this one. I'm pretty sure there are some adapters that could make more commonly used probes to fit this multimeter, but ultimately this is not the case. So I will take out the battery inside because I do not need to have it any longer in there. Place again the screw. The plastic case is not bad in the sense that I think it can survive a bit of shocks. The scale, I think, as far as you can tell, and also through how much it deviates even in normal use, I think you can readily have a good understanding of the product's quality. As you can see over here, the deviation is a lot smaller at similar forces being applied, which means that this meter is also going to be much more affected by vibration, or in the case of using it at a certain angle, you can see that the needle deviates much more than it deviates in the case of even this cheap meter. As you can see, and think about the fact that the scale is much larger, as the deviation is much smaller. So actually this is the product we are faced with, and if we are going to read about the interesting features on the back side, 7 ranges DC position, 4 ranges AC position, 2 ranges home position, yes, it's actually very poor, and you cannot find any sort of detail about accuracy, which I think is very poor. When you are looking at this device, it's about 3% accuracy at full-scale deflection. Keep in mind that some of these devices are not calibrated that well out of the factory, so it means that the deviation may be slightly higher or lower than your expectations, and probably is not going to be easily determined. However, or at least not for me, and with a reasonable, let's say, patience. So you can have all those capabilities, but even in the case of product variability, you still have a reasonably accurate device you can start working with, even if you are a hobbyist or you are someone that tries to find out new ways of checking devices, or is actually very curious about that. On the other hand, this particular meter is very poor. It has poor precision out of the box for most measurements, and I think that it's way off. I mean, 5% full-scale deflection accuracy. I'm not even sure if this is the case. It may be higher. All right, easy to read 3-color scale. Yes, that's not particularly useful. It has way too few ranges. I think that the 1000 range is even pointless with a modern multimeter, and particularly with these poor probes. Mirror scale reduces parallax errors. Well, there is no mirror scale. This means that they were talking about a different device. Recessed safety input terminals. Yes, they are recessed, but they are not great. And safety depends on what you're considering as being safe. Pocket size and lightweight, that's true. Ideal for testing electrical and electronic circuits. No, and particularly not any modern ones or ones that require accurate measurement. Ideal for shop, office, home, boat, car, and farm. Clearly not, and particularly with no fuse. Yes. Sensitivity 2000 ohms per volts per DC per AC. Think about this value is also printed on the meter itself. This meter also have, if you can see over here, has 20 kiloohms per volt DC, so it's 10 times higher. And think about such a device is not being priced at 2 times the one for the SAMWA YX-1000A. So again, another very poor choice. Unfortunately, 25 years ago, there may not have been a lot of choice, at least for analog multimeters and for starter ones. So you would have to, and think about it, there were very few places where you could read about modern devices you could buy. So you were mostly left with the chance you found at your local electronics shop. Alright, what else? Sensitivity 2000 ohms. Yes, it's 10 times less than that one, and this translates to a lot of measurement deviation or inaccuracy. AC voltage 0 to 10, 50, 20, 250, 1000 volts, I already mentioned. What are my concerns? I would have preferred to have a lower voltage test, at least on the DC range, and probably one other on the AC range, on the DC current range. Resistance, I cannot mention too much about resistance. I think that it's okay for a single battery. But it should have had a higher accuracy. And actually I'm going to mention one last aspect about it. How much such a device costs? Probably around, let me think, less than €5 and probably around $5. So that's the whereabouts. I don't think it's expensive. I think it's poor for what you may be buying in the current market. What I wanted to mention in the end was that this device is useful mostly as a curiosity, but not as a serious multimeter. I think that just about any multimeter, be it digital or analog, fares a lot better than this one. But if you want to see how we handle certain tasks when we didn't know any better almost 30 years ago, I think that this device has a very good way of telling a story. So I hope you enjoyed the video, and if you did so, then thank you very much for watching.